Hey everyone, I'm Luke Landaiche. I will be the reporter for Lab 2, which was the bomb calorimeter experiment. My group members included Jacob Campese, Michael Quigley, and Jonathan Globe. So just a quick overview. I have the bomb calorimeter on the left, the schematic for it. As you see, the bomb cell's in the middle, and you'll have the sample inside the can't really name that. You put it inside the bomb cell. The two samples we used were benzoic acid tablet and a food sample. On the outside you'll have water, which will be stirred using the stirrer to make sure the temperature stays uniform throughout the fluid. And then you'll have a thermometer to record the temperatures and an emission box. And on the right is what it actually looks like in the lab. At the end of the experiment, you're supposed to take the leftover wire and measure it. This will give you the total remainder of calories you have left. As you see, the increments let you know how much that is. And then the right is the actual sample in the crucible, which will go inside the bomb itself. For our first trial, the benzoic acid tablet did not fully burn during the experiment. This could have been done based off of maybe the wire coming loose from the sample during the experiment. Due to this, the experiment would need to be repeated. So coming up, I have the results for that. As you can see on the left is the benzoic acid tablet temperature change, and on the right is the food temperature change. As you can see, they follow a similar trend. The change in temperature for the benzoic acid tablet was 2.43 degrees Celsius, whereas for the food, it was 2.14 degrees Celsius. The low temperature is the heat of ignition, the temperature of ignition for the tablet and the food. So for the tablet, it was around 23.5 degrees Celsius, whereas for the food, it was around 21.75. And the high temperature for the benzoic acid, when it reached equilibrium, was around 26 degrees, and it was around 24 for the food sample. So the first step was to find the thermal capacitance for the benzoic acid tablet. You do this using one of those two equations at the top. This comes from the first law of thermodynamics. And combined with the known mass of the benzoic acid, which was 0.93 grams, convert that to moles. And then you use the known heat of combustion for the benzoic acid tablet. This was around 3,200 kilojoules per mole. Using the mass with the heat of combustion, you multiply those together to get the total heat for the benzoic acid tablet. As you can see, it's around, you get 24.5 kilojoules, you convert that to calories. And then you have to use what was left over from the wire, which I believe was 4.5 grams, meaning that 5.5 was consumed during the explosion, or the burning. Anyway, so the thermal capacitance is the total heat divided by the change in temperature. So the final result was around 2,400 calories per degree Celsius for the thermal capacitance of the benzoic acid tablet. Secondly, we're supposed to use a sample or a fuel that you do not know the heat of consumption, like we did for the benzoic acid tablet. Using the same thermodynamic equations, we knew the food mass was 0.9 grams, and that from the food nutrition, it had a thermal capacitance of 5,000 calories per gram. Using those two, you would multiply them together and divide by the change in temperature to get the thermal capacitance, which is around 2,100 calories per degree Celsius. Multiply that by change in temperature to get that back to your gross heat that will be released from the sample, and then adjust from what was remaining or what was consumed of the wire during the explosion, and that came out to be just under 4,500 cal. Compared to what we expected from the tested food, it was just a hair under the 4,500 for the heat, which is right in line with what we expected from the nutritional facts. The same goes to the calories per gram. that was consumed at the bottom there. In conclusion, the data collected by the team was accurate due to how close the values lined up with the nutritional bags. The only error was that the first benzoic acid tablet did not fully burn, but that was accounted for by doing a second trial, which was performed successfully. With all that said, there was less than 1% error in calculations. So, yeah, that's the conclusion. Any questions? Thank y'all.